am Caspian Brand with Synesys.io, and I'm here today with George Wagner, Director of Technical Marketing at Liquid. And we're excited to show you this groundbreaking technology that they have. And just as a quick recap before I hand things over of Synesys and who we are, we've been around for over 20 years. We specialize in integration solutions, custom development. A lot of us are all actively engaged in creating using the same tools that our customers use. And we kind of use ourselves as guinea pigs and figure out nice solutions and clever ways of solving problems and facilitating advanced workflows. One of the things that I mainly come from myself is dealing with shared storage, and I've been speccing some of the Liquid solutions into some performant caching systems for storage. And one thing that I find unique about what they're doing now is what we've seen with shared storage over the last 20 years of things being more dynamic and shareable. Liquid is now taking that same concept to other parts of our processing demands. And with that, I would like to hand things off to George so he can show you what I'm talking about.
Awesome. Thanks, Cass. Really appreciate it. And thank you, everyone, for taking time out of your schedules today to learn about what we're doing here at Liquid and how this could possibly help you in your endeavors in every phase of your workflows. So as I mentioned, George Wagner, Director of Technical Marketing. I'm also joined by Blake Scott, who's Senior Systems Engineer, who'll be doing a demonstration of our software at the end of my presentation. Both of us come from a generally enterprise IT background. However, I do consider myself to be quite the creative person. I used to teach Photoshop classes a while ago, and I guess my link to M&E is that I went to high school with Doogie Howser. How about that? So that's about it for me. But today I'm going to give you an overview of a new technology called composable infrastructure, and really how it'll be able to help you unlock new levels of efficiency in every phase of your production workflow. When we look at some of the challenges facing M&E today, your projects, you're dealing with massive amounts of data, as Caspian was saying, and that data needs to be processed. It needs to be accelerated, and the resources that are required to do that are very expensive. We're talking about GPU, NVMe flash, memory. Caspian mentioned caching. Caching can be quite expensive, especially when you're trying to get into the terabytes of size. So, we're dealing with these very valuable, costly resources, and we need to find a better way to manage them and to ensure that that utilization is maximized. So there are a couple of choices we have today, not only in the M&E space, but also in the enterprise, and that is hybrid IT. Right? So it's really the reality. For many folks, there's some amount of data, some amount of processing compute that's occurring in the cloud, and some portion of it on-prem. And depending on the application workload, it's the ability to transport it back and forth. And those are kind of the dependencies which determine what's on-prem versus what's in the cloud. And one of the major benefits, obviously, of public cloud is the massive levels of flexibility and agility that are enabled there, right? However, on-prem gives you that cost benefit, right? And when you're talking about moving massive amounts of data, especially in your world, it can take forever to move from cloud to on-prem. So really, there tends to be this perception that there's a trade-off. That's an accurate perception, that there's a trade-off between the cloud and on-prem, which is flexibility versus cost. And we look under the covers to figure out why that's kind of the notion, if you will, is that conventional IT vis-a-vis workstations and servers and the way they've been architected for years is really at the core of what we're dealing with. And both Blake and myself were IT managers back in the 90s and early 2000s. And I can tell you from experience, not much has changed as far as the way that workstations and servers are built. things have gotten faster, right? Multiple cores and processors, support faster and more and support for higher densities of RAM, capacities for storage, and GPUs are no longer used just for gaming anymore, right? They're used for accelerating video. But at the end of the day, it's architected the exact same way, right? You essentially go out and create a configuration based on a future need. That future need is in this server or this workstation needs to last for 3 to 5 years. So you work on getting this configuration. You wait 3 to 5 weeks to have it delivered. You have to rack and stack it and get it going, and then pray to God that it's going to meet the needs of your workloads in the future. What if it doesn't? And typically they don't. Then it requires that you scale the system. Now there's a couple of challenges here. First challenge is there's a limited amount of scalability you can do within the box. You're confined by the form factor, right? Is it 1U? Is it 2U? Is it a tower? How many PCIe slots do I have? If I do have enough space, great, I can add cards to it, but it requires downtime. I need to schedule downtime. If it's remote, I need to send someone out in the field to crack that open and add cards to it. So there's lost time, lost productivity that's incurred there as well. If it can't scale, that's a new server, that's a new workstation. And then also, when we buy these systems, we tend to over provision, right? Because we want to make sure that our producers are producing. And if they don't have the resources to do that, then they're going to get angry and complain, as I know from my history. But also, if they're not productive, if they're not producing, they're wasting time, and time is money, right? So if you have GPU, for example, that are sitting in a server and that are being underutilized, that's wasted money. And as we all know, those resources are quite expensive. So what we set out to do at Liquid is to really reimagine the data center and really enable you kind of unlock that traditional x86 environment and allow you to connect resources you need, whether it be memory, whether it be graphics, whether it be storage, directly to your systems via software. So in seconds via software. What's the advantage there? Well, you're no longer limited by what you can put in a system physically. We're creating, as you'll see in just a moment, we're in essence extending the motherboard outside of the system. So you're getting direct attached performance without having to directly attach to the system. And because we're doing it via software, we can move these devices around on the fly as needed to address any of these needs, and also maximize your resource utilization. So if GPU isn't being used in one workstation, we can move it. So how is this being done? The technology is called composable disaggregated infrastructure. And as I mentioned, this is really a way to reimagine infrastructure and taking those static configured systems and turning it into a dynamic data center that really allows you to do anything you want. I would venture to say, you can actually quote me on this, we can probably deliver better than cloud flexibility and agility on-prem. I mean, if you've ever dealt in public cloud, there are different configurations, as you'll see in just a moment, that you could choose from, but you really are kind of locked into a finite amount of configs. Really, you can consider kind of unlock the impossible here with what we're doing here at Liquid, and kind of how it works for those of you who are technically inclined and want to know. What we're doing is we're taking resources that are typically in the servers, GPU, Optane memory, storage, FPGAs, NICs, and we're disaggregating them from the servers. So instead of having these resources sitting in the servers, confined, locked, and unable to share them, we put them in these resource pools and connect them to a high-speed fabric, PCIe fabric, right? The same slots you're plugging your devices in on your systems and your workstations, we're plugging these in, but remotely. And across this fabric, we have our software, Command Center software, which is kind of the secret sauce. That's where all the magic happens. And with the software, we're actually able to create any system that your producers, that your workers, your compositors, your renderers require. Whether it's a server with 2 CPUs, 4 GPUs, 20 terabytes of storage, done. It really makes no difference what it is. It's kind of creating the impossible, as I said before. And if we kind of go through and talk about what this addresses from an M&E, kind of the M&E perspective and the challenges they're dealing with and you're dealing with, this gives you the acceleration, the storage performance required to improve compositing and tracking, virtual production, for example. So really, that final piece where you're putting everything back together and requires large amounts of RAM workspace, we can provide that and provide it, in it temporarily if need be, and then move it on to the next server where that individual, that process needs to work on this on a very similar workload with the similar demands. Interactive video editing. Data duplication. So I'll show you at the very end of this some of our lightning fast NVMe flash and Optane storage options that can also be composed in the same manner that I'll show you, and Blake will show you towards the end. So there's really two ways that we can deliver this, right? There's delivering kind of whole hog servers, right? And that might be interesting to some folks. So if you are looking to compose entire systems, servers, GPU, RAM, and do that to meet precise requirements, that's this use case. And we call it dynamic bare metal as a service. So let's say you have applications that you need to spin up frequently, and you have resources that you have servers today in your existing environment that you're trying to match. A lot of times you mismatch applications to server resources, right? This application needs one GPU, but I have a server or a workstation with two. Well, that's all I have. Let's apply that. Let's merge these two guys together, and often that ends up being a mismatch, right? And you end up having resources that are being underutilized. And when you're underutilizing resources, you're wasting money. What we're able to do is, in fact, create templates of workstations and servers in the configurations that you require. So when an application need or a workload need is present or pending, I can go ahead and just say, okay, spin up template A, which is a small template, and assign to this workload. This one's a bit more performance intensive from a GPU perspective. Select template B. It'll go ahead and create the server and amalgamate those compute resources, memory resources, GPU, all of that together into a single server. And spin them up and spin them down in seconds. It's quite simple, as Blake will show you. Now that's one way to do it. And when I was really talking to Caspian and the folks at Synthesis earlier, they mentioned that the second use case might be very interesting to the folks on the phone, and that is GPU time sharing, resource time sharing, and being able just to move resources around in your existing workloads. From your existing workstations, not workloads, but your existing workstations and servers. So this is the first example I'm going to show you, and this is an actual customer that we have. It's a production studio in Southern California, and they do a lot of work in video games and movies. I can't name names, but that's what they're doing. And they came to us with a specific challenge. The challenge was that they had AI engineers that were doing work during the day hours, say 8 o'clock to 4 p.m. And those workloads, those engineers required the performance equivalent of 4 GPU. Okay, but at night they also wanted to be able to do video rendering in the off hours, and that type of workload also required 4 GPU. So their alternative was to go out and purchase 8 GPU, high-end GPU that were quite expensive, lock them into those workstations, and just let them go off and do their thing. The other option was to talk to Liquid, and with Liquid, what they're able to do is just take 4 GPU that they already had, put them into an enclosure, an enclosure that we use to pool our resources or their resources, and then use our software to provision it to the AI engineers during the day, right? And they're able to pound away and do their work. And then at night, They take those same GPUs and they compose them over to the video rendering workstations. And that work go all evening into the morning and then switch it back. That was all scripted. It's all automated. And in essence, they were able to double their GPU utilization over what they were currently doing. Reduce capex because they didn't have to go out and buy those GPUs, extra GPU. And guess what? When let's say that the video rendering, maybe they no longer need to be doing that. Maybe they have a third workload. They can go ahead and move that around as well. So this is just one example. We call it time sharing, but it definitely enables you to maximize these valuable and costly resources. The second one is the ability to allocate GPU to any server real time. So I know for many of you, you may have farms of workstations that are currently doing this work, whether it's compositing, whether it's something along that production workflow, and they require GPU. Well, they may not all require GPU at any time. Maybe it's more compute intensive, right? CPU intensive. Other times, maybe it's it's leaning on the RAM more so, and so they don't always need the GPU. So what we allow them to do is to take pools of GPU and simply provision them to the workstations. Right? So I can move them from workstation 1, and workstation 2 now needs it. Workstation 1 doesn't. I can move 2 over there. I can move 3 over there. In fact, kind of in the absurd, maybe, I don't know, but we can go upwards of 16 GPU into a single server. So, and really not ever worry about the form factor being an issue, right? Because this is completely external to those workstations. So with this, we can overcome the form factor limitations. We can move them around in seconds. And once again, you don't have to over purchase GPU. So really maximizing that utilization. The other one is the ability to extend memory. So when you're doing interactive editing or other types of work within the workflow that require massive amounts of memory, DRAM is quite expensive. Right? So one of the ways we can overcome that is by using Optane. So if you use Optane, Intel Optane memory with their IMDT software, you can take and essentially add to the cache within the memory. So you have a massive workspace. So instead of using 3 terabytes, having 3 terabytes of RAM, which can be upwards of $27,000, you can augment that with a smaller amount of RAM with Optane and get to a massive memory space for a fraction of the cost. And pairing that with Liquid, now we can take and compose that to the different workstations as needed, kind of on demand. Right? So high-speed workspace, much less costly than DRAM. If you look at DRAM compared to DRAM plus Optane, if you just bought 3 terabytes of DRAM, it would be about 27 grand, as I was saying. If I wanted to get to 3 terabytes of DRAM and I just added Optane to a fraction of that, I can go for about 6 grand. Or I can get up to 12 terabytes of DRAM and Optane for about 24,000. So it's pretty cost effective, and with using composable infrastructure, being able to flexibly move that in and out can provide much more productivity for much less cost. When we talk about how it's done, putting it together, it's quite simple. As I mentioned, the purpose, or I said, the capabilities we have are to take an existing data center and essentially take it and make it more dynamic. So we're not taking a data center and ripping it out and replacing it. We're just making what you have more efficient, right? More flexible, more agile, more efficient. So what we're doing here, when you put it all together, is taking a PCIe HBA card or Ethernet. We can actually go over PCIe fabric or Ethernet fabric. You plug that card into a workstation, a server, as long as they have an open PCIe slot, and then plug that into the fabric. So that fabric can be PCIe, which is a switch that Liquid makes. We make our own PCIe fabric switches. that has the software or command center software on the switch itself, or it can be off the shelf 100 gig Ethernet. Just know that you can't compose GPU over 100 gig Ethernet. You got to compose it over PCIe. But if you had NVMe storage, you need that. Caspian is talking about how shared storage has been around for a long time. We're starting to see it change a little bit. Shared storage is fantastic, but it's not direct attached, so it's a little bit slower. Right? So there's more latency incurred there. But if I can take NVMe storage, for example, and put that directly onto, or put that in Compose system, it acts like it's directly attached, and I can do that over Ethernet. So NVMe over Fabric, we do support that, and in fact, you could do both NVMe over Fabric and PCIe, in your same environment. So it's and one of the benefits of NVMe over Fabric is you can go distances with that as well because you're going over Ethernet. Sorry, I didn't mean to ramble too much, but just understand that's all connected into the switch, and then you simply take our expansion chassis and plug those into the switch as well. And those expansion chassis would contain GPU, some combination of GPU, storage, whether it be NVMe or Optane, and then from there you can provision that out. If you look at kind of what we're doing from a component standpoint, what we offer, hardware and software, this is really it, right? It's the fabric, right? And there are the expansion chassis. And we have multiple expansion chassis, that hold different amounts of resources, accelerators, storage that are running in PCIe version 3, which is PCIe 3.0 is about 150 nanosecond latency, and in 4 is 100. So very low latencies for lightning fast response times, which is what you need. And in compute, compute is, we do offer that, but that's something that you have on your own, and you can obviously get all of that through Synesys. But whether it's workstations or servers, I mean, for example, workstations and servers are essentially the same thing, right? They're just different form factors and different powers. So, but you can plug into either one of those. We do have the ability to do GPU scale out. So if you have, we have this large box here called the Sumo. This box here on the upper right, and it can hold up to 20 GPU, which is pretty insane. And it can directly connect to up to 4 workstations or servers. So you could, if you needed strictly GPU and you had, a number of servers, say 4 servers, you wouldn't need a switch at all. You can just plug the servers directly into this box and go, and start with a small amount of GPU and add up from there. We're agnostic from a hardware perspective, so you can choose any GPUs you want. Typically, most of our customers are using NVIDIA, and plug those into the servers and go. If you wanted to go beyond 4 host connections, 4 workstation connections, then you go ahead and add a switch into that environment and grow from there. But the beauty of this is, you can compare it to, for those of you familiar with the NVIDIA DGX2, that can hold 16 GPU. This guy can hold 20 GPU, about half the cost and 25% more performance. So it's definitely a very economical, better economics when you compare it for more performance, which is excellent. One thing that was also mentioned early on before I hand it over to Blake is that we also have NVMe devices that are composable ready. In fact, they're extremely fast. And so when you're talking about needing to copy massive amounts of data between cards or between systems, between cards, move things around, these are the fastest in the world. In fact, this guy, the second card here, we call it the Honey Badger, the 4500. So we offer add-in cards, full height, full length, and half height, half length cards that are both NVMe flash and also Intel Optane. The Optane cards, they're on the far right, or they can either be dropped directly into the system and used without our composable software, if you weren't quite ready for that yet, or they can be put into our enclosures and composed between systems. So as you can see from a performance standpoint, this 4500 here, the second one, and it can do 4 million IOPS, which is pretty insane. And then the latency, throughput, 24 gigabytes of throughput per second is pretty incredible, and that is the fastest in the world clocked right now. And these Optane systems over here, if you look there, they have a ton of endurance. So the final card there, the Intel Optane card, the 4900, 328 petabytes written for endurance, so it can sustain a massive amount of writes to the system. So those are definitely possibilities, and we definitely love to entertain a conversation on that with Synesys if you have any questions. But I wanted to not make my presentation too long. I wanted to open it up for questions. When Blake is done. So if you have questions, hopefully they're coming in. We'd be happy to answer them live. And just to kind of sum things up, what we're really delivering are three things, right? So increased flexibility, as I mentioned, kind of better than cloud flexibility. So create any server configuration. We are completely agnostic. You're not tied into a particular vendor from a storage perspective, GPU perspective, any of that. From an agility standpoint, you can take and assign GPUs to any server without having to crack it open, without having to schedule downtime, move things around on the fly, which is, as we know, time is money. If you can make your staff, right, those workers more productive, that allows you to take budget and divert it to other areas to provide value. So scaling up, scaling down. From a management perspective, Blake will show you the demonstration through our GUI, but we also have a CLI and API. He'll talk about that. And then finally, that reduced cost from a management standpoint. So we're enabling as a service functionality, which lowers your operational expenses, but also because we're sharing out these resources, we're reducing your hardware purchases and maximizing resource utilization, which makes you a hero in the CFO's mind. So, and we've heard that quite a bit. So with that, I'm going to pass it over to Blake. Just a second here.
Hello, thank you for joining me today. My name is Blake Scott. I'm an SE at Liquid, and it's my pleasure to show you a demonstration of our user interface and walk you through how easy it is to set up, configure, manage, maintain your composable infrastructure. So what is composable infrastructure? If you look at this first component, we define this as a fabric. So for us, a fabric is anything that's connected into the fabric switch, in this case, PCIe. And fabric is a free pool of resources available to you that then you can use to create machines and host out to users for different workloads. And the point is we could do this quickly and dynamically with very little downtime, if any, and you can do it remotely from wherever you're working from. So just to kind of take a look at the fabric in a couple different ways. First of all, in the virtual picture that you see here, you see all of these PCIe resources categorized and ready to be utilized. Another way to look at it is from a physical perspective. So what's great about this is that this is the actual layout of my architecture, including, so this is the fabric switch, then these are the actual ports that are on the switch, and it gives me an idea of what's connected or not connected to these guys. So in this case, for example, on port 8, I've got an actual 1U Dell R240 and an R260. If I'm troubleshooting this remotely, and I know that this connection is down, well, that gives me a really great place to start, or to guide somebody who might be at the data center and is able to help me. I could say, I'm seeing some issues or an error on port 8, could be the cable, could be the device, what have you, but at least I'm starting at the basic level, the ground floor of troubleshooting, and I'm not jumping to a bunch of conclusions. And so hopefully that, at least in my experience, this is a beneficial way to go about taking care of your environment. Some other stuff that you can see here, and I'm trying to make it a little bit bigger so it's easier to see, but on this port 20, I've got an enclosure, and in this case, the enclosure has room for multiple PCIe devices. things including GPUs. I've got a couple of NVIDIA Tesla T4s, and then a variety of solid state drives, NVMe, with different types of NAND flash on them, Phison or Optane, different things like that. But I can find a lot of information. The generation of PCIe it's based on, and some other things to help identify it, which also helps me when I decide to use those resources and combine them to be hosted and accessed by users. So how do we set this environment up? We start off by creating a group, and a group for us is a delineation of resources. So in this case, I could call this a variety of things. I'm going to go ahead and name it video editing for fun. And I'm going to go ahead and acknowledge it or select it. And that group itself could be a segment of your business. Maybe it's a department, maybe it's a location, maybe it's multi-tenancy where you're hosting multiple customers, and you've got to really have a brick wall security between those physical resources. And since we're making bare metal servers here and isolating these resources, and they can only be accessed by one machine at a time, meaning that I've got a lot of security and a delineation between those different environments. So once I have the name of my group, then I'm going to go ahead and add those resources from the free pool. I'm going to add a CPU, a GPU, and I'm going to go ahead and add just a couple of SSDs. When I click done, then those are going to be attributed with that group. Now I'm going to go down and create a machine. Machines are important because this is really where the rubber hits the road. This is a user accessible environment now. It could be a virtual desktop. It could be a host machine. It could be a whole variety of things. But the point is that this is real time in our lab in Broomfield, Colorado, and I'm working remotely, accessing these resources and configuring them, and then I'll show you how to change them. Once I have and I meant to type ingest, once I have this machine created, I'm going to add those resources that were in my group. So I'm going to, again, a CPU, a GPU, and I'm going to add a couple of SSDs. When I hit the reprogram button, now this is electronically on the back end of my environment, connecting the PCIe bus to this available PCIe resource, essentially. And once that green device stops spinning, I know that I've got that machine created. And one way to know that is I can go into my Linux environment, my back end, and I can take a look at the devices that I've got. And I can do a search, basically show the hot pluggability of actually validation of these devices being connected. And you can see here, I have 2 hard drives connected. And I'm also going to take a look for that NVIDIA card. And there's that device right there. So if I have, say, multiple devices in my environment, and one of them goes down or I want to make a change, I can easily go into this device and say I've decided that I don't need this many hard drives, so I'm going to remove those from this environment, hit the reprogram button, and now I can go back in and take a look at that and see the change has occurred after that's complete, right? So I still have the GPU, but what I don't have are those NVMe drives. They're gone at this point. And so I've taken them out. I haven't had to open up anything. I haven't had to remove anything physically. I haven't had to reboot any servers. So that's all from a hot plug perspective. So now say I want to go in the other direction. I'm going to look at my fabric and see what I have available. Most of this stuff is allocated. In this group itself, I can go back and see what's available. I can add those SSDs, and I can remove, say I want to add these SSDs here. At the same time, I'm going to remove one of the GPUs. Okay. Now I'm going to go to the other side, to my other device. And once everything is committed, then I get the option to add that GPU, which is what I really wanted to show you. So now what I have, again, I'm going to commit that, and then I'm going to go into my machine. And I'm going to add that device using, again, the plus minus sign. I'm going to add a GPU and a couple more hard drives. And I'm going to hit reprogram. And again, I'm going to take 15 or 20 seconds. Then I'm going to open up the command line option and show you what we've got. So I've got the extra hard drives in there, and I've got the GPU. And then on the other side of my environment, do the same thing. And no NVIDIA card, it's been removed. So that's the flexibility that we have within our environment. And there's just a couple more things I want to show you. So if I wanted to take that same machine and say, take it from bare metal and add an operating system on it, I click the OS button. I've only got 2 ISOs currently loaded. Any image that you want, image file or ISO file, you can upload to the environment. Typically, we see Ubuntu, CentOS, Windows environments, things like that. I'm going to highlight that, and you can see I don't have a hard drive. Actually, I have this SSD I can use, so I can install that operating system on that exact device, that actual drive, and do that again while I'm remote without having to manipulate anything from a physical perspective. So that's that from that perspective. So just kind of wanted to walk through. If you have any questions, please let me know. Again, appreciate your time, and let me know what you think of the product. I think it's pretty cool, very functional, and we're pretty proud of it. So let me know what you think. Thank you very much.